So yesterday we talked about slope of a line, which talks about how steep a line is. And today we're going to talk about what's called the rate of change. So if you notice, it says the rate of change for a function is the ratio of the change in y, the dependent variable, to the change in x, which is the independent variable. So that sounds a lot like what? What did we talk about yesterday? That was a ratio between the change in y and the change in x.
The slope.
The slope. So it sounds a lot like the slope. So we're going back to the situation from yesterday. Now Margot is going to actually build the ramp. So she went to the lumber yard to buy supplies to build the wheelchair ramp. She knows she will need several pieces of wood. Each piece of wood costs $3. So first they want us to write a function using f of x for the total cost of wood pieces if she buys x pieces of wood. I'm at
F equals 3x.
f of x equals 3x. Why did you say 3x?
Because each piece of wood means it's x and it costs $3, so one piece of wood would be 3.
Yes, so each piece of wood costs $3, so you're multiplying 3 times the number of pieces of wood. So this function would be f of x equals 3x. And now we are going to take that function that we just created, and we are going to make a table and a graph. So for the table, can I have negative numbers on this x value?
No.
Why not?
Because you can't have negative wood.
You cannot have negative pieces of wood. So let's just go ahead and start at 0 to make this easy. 0, 1, 2, 3, 4, 5. So if I plug in 0, how much would that cost if she bought 0 pieces of wood?
0.
$0. What about 1 piece of wood?
3.
2 pieces of wood?
6.
3 pieces of wood?
9.
4 pieces?
10. 12.
And 5 pieces?
15.
15. So go ahead and graph that on your graph. Watch out because they're counting by by 2s at the bottom and by 3s on the side.
I did it wrong.
So our ordered pairs make a what when we graph them? They make it's a straight line. So it wants us to find the slope of that line. So we need to find the rise and the run. So we're going to pick any 2 points that we want and find the rise and the run between them. So if we pick from this first point to the second point, how far up does it rise?
3.
3, because it's counting by 3, so make sure you're counting by the right amount. It rises up 3, and how far does it go over? 1, which reduces to 3. Part D says, how much does the cost increase for each additional piece of wood purchased?
3.
Right, it increases by $3. So, how does this slope relate to the situation?
Tells you how much the cost is going to be for
Right, the slope was what did we just find the slope to be?
the cost.
$3, which was the same as
How much it costs to buy one piece of wood?
what? Right, so the slope is the same as the cost per piece of wood. Is there a relationship between the slope of the line and the equation? So the slope was 3. What was in the equation? 3. So yes, there is a relationship. And it says to describe the relationship. So yes, the slope, which is 3, Where is it in the equation? Before the x. And that number before the x we call the coefficient. So the slope, which is 3, is the coefficient which is the number before x. Of x in the equation. All right, now we're still talking about Margot, but we're going to talk about something different. Margot is now going to go to work with a local carpenter during the summer. Each week, she earns $10 just for going to work. She gets $10 plus $2 per hour. So now we need to write a function for her total earnings if she works X hours. So f of x, Destiny,
F of x is 2x plus 10.
2x plus 10. And why do you say that?
Because she gets $2 for going to work and $2 per hour.
So what does the x stand for?
So amount of hours.
The amount of hours she works. So she gets the $10 just for showing up plus $2 per hour with x being the number of hours. So again, they're asking us to do a table and a graph for this function. What can our x values be? They have to be positive. You cannot have negative hours. So it's probably easiest just to do 0, 1, 2, 3, 4, 5, 6. And then go ahead, we're going to plug this into this equation. So for 0, you would be doing 2 times 0 plus 10. So 0 plus 10 is 10. So if she works 0 hours, how much money does she make? $10. So go ahead and figure out the rest of this table on your own. So for 1 hour, how much would she make? $12. For 2,
14,
16, or 3,
16,
4,
18,
5,
20,
and 6.
22.
Okay, and then make sure that you have this graphed correctly. So we would have 0, 10, 1, 12, 2, 14. Make sure that's all on your graph. I'm going to go ahead and connect these dots. Can I draw an arrow on both sides? Which side can I draw an arrow on? The top right. Why can I not draw an arrow at the bottom? You would start getting negative hours, and we can't have negative hours. So our line starts at 0, 0, and it's going to go up because she can get more than 6 hours. All right. Letter C on the next page. I just want to answer this last question of part C. How much do her earnings change for each additional hour worked? Right. So she earns $2 more per hour. Does it have a constant rate of change?
Yes.
Yes. What is it?
2.
2. What is the slope of the line that we just graphed? So go back and look at the line. If I'm trying to find the slope, if we start at the first point, how far up do we have to go to get to the next point?
2.
2. And over how much?
1.
1. My rise over 1 is 2 over 1, which reduces to
2.
2. So going back. What is the slope of the line? We said that the slope is 2. Remember, M stands for slope. What is the meaning of the slope within the context of her job?
The cost per hour.
Right. For each hour she works, she earns $2. What is the relationship between the slope of the line, the rate of change, and the equation?
They both involve change.
They all have what?
They all two.
2. They all have 2. So the slope is 2, the rate of change is 2, and the equation has a coefficient of 2. How much is she going to earn if she works for 8 hours? So how right, how can we figure that out?
8
8 times
2
2
times
plus
2 plus 10.
So we plug it in, and we do 2 times 8 plus 10, so that would be 26. So she would earn $26 if she worked 8 hours. All right, so we're still talking about Margot. She worked all summer, and she saved $375. Recall that the small pieces of wood she wanted to buy cost $3 per piece. So now we're going to write a function for the amount of money that she has left after she buys the wood. So we know we have f of x. What are we going to start with? How much money does she have to start?
$375.
$375. And what's happening?
She's
dividing.
dividing.
So
We take away 2.
take away, right. You are subtracting 3x because you are subtracting $3 per piece of wood that she buys.
She just divide by 3 to see how much she gets.
Well, she might not want to spend all of it.
Huh?
She doesn't want to spend all of it. She's just going to spend some of her money.
Oh, okay.
All right. On the next page, we're going to do a table and a graph. And you can really choose whatever numbers you want, but I'm going to give you some easy numbers to choose. So we're going to do 0, 25, 50, 75, 100, and 125. So let's go ahead and plug those numbers into the function that we just came up with. What do you get when you plug in 0?
375.
375. If she doesn't spend any money, she still keeps all of it. What about if she buys 25 pieces of wood?
300.
She has $300 left. What about when she buys 50 pieces of wood?
225.
75,
150.
100,
75.
and 125.
0.
0. So go ahead and grab those numbers if you haven't done that already.
I got it.
All right, so when you connect these, again, we get a straight line. If you can draw a straight line. All right, and again, how much does it change for each additional piece of wood that she buys? $3. So for each she saves, or she loses $3 for each piece of wood she buys.
Is it I before E or E before I?
I before E except after C.
Okay. Wait, so it's E before I?
No, I before E except after C. We're before C.
Oh, okay. So I.
All right, does this function have a constant rate of change?
Yes.
Yes, what is it?
75. Money.
It is -3.
What?
Because how much is she losing each time she buys one piece?
Oh, 3.
$3. The only reason it was going down by 75 here is because I skipped around with my X's. If I had gone 0, 1, 2, 3, they would have gone down by 3 each time. So, yes, it has a constant rate of change, and that rate of change is -3. What is the slope of this line? Start at a point. If I start at this top point, which was 303.75, and I go down, how far did I have to go down?
375.
I had to go down 75
375.
and over
25.
25. So 75 over 25 reduces to 3. And it was a negative 75 because I went down, so it's negative 3. How are the rate of change and the slope related?
They're the same.
They are the same. Do y'all want to take a guess that, how they're always related? They're always going to be the same. The slope and the rate of change in the situation will always be exactly the same. So, part G, describe the meaning of the slope within the context, which we already kind of did in part C. So it's the same thing. She loses $3 for each piece of wood that she buys. She loses $3 for each piece of wood that she buys. And how is this slope different from the other two slopes we've talked about so far today? It's negative. This is the first one that's negative. It goes down instead of up.
Oh, that's right. But she's losing the money.
Right, she's losing money. Alright, so on the top of the next page, the constant rate of change of a function is negative 5. Describe what the graph would look like if you were reading it from left to right. Which direction would it be going down? Up or down?
Up.
What is negative?
Down.
Down. Negative 5 means it's going to be going down. Down how much? 5. And it's going to go over 1. Yes. So the graph would be going down 5 and over 1.
Why over 1?
Because it's a whole number, so it's always over 1.
Oh, right.
Alright. Number 5 says, does this table represent data that has a constant rate of change?
No. Well, wait.
So let's look at this. How much does it change between 2 and 4? 2. Between 4 and 7? 3. Between 7 and 11? 4. What about between negative 5 and 5?
10.
5 and 20?
10.
15. Between 20 and 40?
10.
20. Alright, now let's go ahead and find our unit rates. What is 10 divided by 2?
5.
15 divided by 3?
5.
20 divided by 4?
5.
So, do they have the same rate of change?
Yes.
Yes. The rate of change is 5.
Yes.
Alright, you need to do 6 and 7. Notice in 6, part B, it says to make a table and graph it. Use this graph paper on the side to make your graph. The art museum charges an initial fee of $50, and for each visit, it's another $15 per visit. So, no matter what, if you go to the museum or not, how much money are you spending? $50. It's $50 whether you go or not. You pay to have a membership with the museum, and that is $50. So it always starts off with f of x equals. So we know we're spending $50 just for the cost of membership. And then how much is it every time you go?
$15.
So we're adding another 15, but we don't know how many times you're going, so it's going to be 15 times x, and x stands for the number of times you go. It's also okay if you had f of x equals 15x plus 50. Either one of those would be okay. Part B asks you to make a table. So you can choose any numbers you want. I'm just going to pick some easy numbers here. I'm going to do 0, 1, 2, and 3. So if you go to the museum 0 times, how much money will that cost you?
$50.
$50 for that original membership.
50.
What about one time?
65.
Twice?
80.
3 times?
95.
95. So then you needed to take that and graph it. On your graph, I would suggest doing the y-axis by maybe 5s or 10s, and the x-axis by 1s. So, no visits cost me $50. 1 visit cost me $65. 2 cost me $80. And 3 cost me $95. So again, I'm going to connect these. I am not going to draw an arrow down because I don't want negative visits. But I can draw an arrow up because my visits will continue. Part C, what is the rate of change? How much is it changing each time you go? 15. It's going to be $15 more every time you go, so that is the rate of change. And what is the slope? The slope and the rate of change are the same. So the slope is also 15. If you went up 15 and over 1, rise over run. So the slope and the rate of change are both 15. How does the slope of this line relate to the number of museum visits?
You gotta add $15 every time you go.
Right. It's the cost. The slope is the cost per visit. And this per word or each, every time you see the word each or per, that normally signifies the rate of change or the slope. Every time you see the word each or per, that's going to signify to you that you are looking at the rate of change or the slope, which are the same thing. Number 7 asks you to determine whether the slope of these two different pairs of points are the same. So first let's look at the first ordered pair, negative 2, 7 and 3, 0. What do I need to do before I do anything else here?
Make sure that it looks the same.
I need to use the slope formula, so what do I need to do first?
X1, X2.
Label the points. X1, Y1, X2, Y2. So I'm using my slope formula. M equals Y2 minus Y1 over X2 minus X1. So Y2 would be 0 minus Y1 would be 7 over X2, which is 3, minus X1, which is negative 2. So 0 minus 7 is negative 7, and 3 minus negative 2, positive 5. Don't forget to keep change. So that's negative 7 over 5. And then the second pair of points is 2, 1, and 12, negative 13. So again, what do I do first? Label them X1, Y1, X2, Y2. So plug this into my slope formula. So Y2 is negative 13 minus Y1 is 1 over X2, which is 12, minus X1, which is 2. So negative 13 minus 1 is negative 14 over 12 minus 2, which is 10. So that reduces to what? Negative 7 over 5. So yes, they are the same. And then we can turn to page 137. We did not finish it. Page 137, we are now doing 11 and 12. So I'm going to give y'all just a couple minutes. These are some pretty simple problems. So for number 11, Juan earned $7 per hour and $20 a week making picture frames. What is the function, now we're using g of x, for his total earning for the week? So g of x equals what?
7x plus 20.
7x plus 20. So it's 7 times the number of hours plus the $20 he gets for showing up that week. Without graphing, what is the slope? 7. It's the same thing as the rate of change. It's changing by $7 for each extra hour. So that would be 7. What is the slope meaning in this context?
He gained $7 an hour.
Right, he makes $7 per hour. All right, now they have a graph of an airplane that's landing. So it starts off at the top at 10,000 feet at 0 seconds. And as time goes on, it gets lower and lower. Does this have a constant rate of change? Yes. How much is it changing?
By 3,000.
So negative 3,000. It is dropping 3,000 feet per minute. So it goes down 3,000 and over 1. So that's 3,000 feet per minute. What is the slope of the line? Negative 3,000. How are they related? They are the same. What is the meaning of the slope within the context?
It drops negative 3,000 per minute.
The plane goes down 3,000 feet per minute.